The term artificial intelligence gets thrown around constantly. One minute it's optimizing your phone's spam filter, and the next you're hearing about existential threats from a sentient sci fi computer. Grouping a basic email sorting algorithm and a self aware digital god under the exact same label makes it almost impossible to understand what the technology is actually doing. Researchers don't actually measure an AI by how smart it seems. Instead, they look at its cognitive versatility, its ability to adapt and function when dropped into a completely new environment. To make sense of the progress being made, the field is broken down into three distinct tiers. You can think of these as the expanding size of the system's operational playground. Understanding these three specific boundaries is the only reliable way to separate Hollywood science fiction from the technological reality we live in today. The first tier is artificial narrow intelligence, or ANI. In the research community, you'll often hear this referred to as weak AI. That label is deceptive. Almost 100% of the AI powering the global economy right now sits squarely within this tier. Rather than thinking of it as weak, think of it like a hyper-specialized power tool, like laser cutters, for instance. It is engineered to execute one specific task with precision and consistently outperforms human ability. A chess-playing AI can calculate 1,000,000 moves ahead and crush a grandmaster. But if you ask that same program to write a sonnet or predict tomorrow's weather, it completely collapses. It has zero generalized understanding. The system isn't lacking processing power. Its intelligence simply becomes useless the moment it steps outside of the strict assigned boundaries of its single playground. That brings us to the massive leap required for the second tier, artificial general intelligence, or AGI, frequently called strong AI. If narrow AI is a highly calibrated laser cutter, general AI is a versatile artisan. And an AGI system possesses human-level cognitive capabilities across any given domain. The defining characteristic here is the ability to transfer learned knowledge from one subject to another. It mimics the natural adaptability of the human brain. An AGI could learn chess instantly, pivot to writing poetry, and then diagnose a patient pulling logic from every previous experience. We lack true AGI today, but achieving this adaptability is the primary target for global research labs. Reaching AGI marks the threshold where a machine stops operating merely as a software tool and begins to function as a truly autonomous, versatile intellect. Finally, there is the theoretical third tier, artificial superintelligence, or ASI. ASI represents an intelligence that surpasses the collective intellect, creativity, and wisdom of every human being combined. While an AGI is an artisan building with the tools we give it, an ASI is an entity capable of inventing entirely new laws of physics to construct things completely beyond human imagination. Fortunately, we aren't anywhere close to that reality. ASI remains strictly in the realm of future casting and theoretical physics, sitting far beyond our current engineering capabilities. It represents the absolute endpoint of cognitive versatility, a state where the machine's playground loses all boundaries and entirely eclipses human control. This spectrum plots the three tiers we've explored. The curve steepens sharply as we move from a single task tool toward an intelligence that can reinvent the laws of physics. Keep this map in mind because it's going to make it easier to filter modern tech news. Now, almost every new breakthrough you see making headlines right now is simply an advancement in narrow AI. The massive multi-billion-dollar race happening globally is specifically focused on crossing the gap from narrow to general intelligence. Now that we have a clear picture of the three categories of intelligence, it begs an obvious question: how do the machines within these tiers actually acquire their knowledge? In our next section, we will look under the hood to break down the specific mechanical differences between artificial intelligence, machine learning, and deep learning, and see exactly how they all fit together. Understanding the boundaries of machine intelligence is step one. Grasping the mechanics of how they learn is what actually allows us to see where technology is heading next.